we are going to define the activation function. We'll be using ReLU activation function. So we'll be ignoring all the negative values from the input. And there is a cache variable for the back propagation which stores the input. Sorry?
Column in the ReLU backward.
Column?
The function ending.
colon.
So, Sana,
Yes.
show us the line number. View, if you go to the menu, there is a view and line number. Yeah. Mhm. Everybody understand the ReLU for the backward function? Saroj, do you understand the for the backward?
Implementation?
Yeah, the source code.
No, not really.
Okay. Do you know what is ReLU?
Yeah, ReLU.
Okay. Who does not know what is ReLU? You don't know what is ReLU? Aishira, you know? Okay. So, Sanas, please explain what is ReLU.
ReLU is an activation function wherein it takes an input and only if the value is 0 or above you get to pass through, and if the values are negative it is considered as 0.
Mm-hmm. Yeah. So Youngtak, I think you have to take some TensorFlow tutorial or PyTorch tutorial. It is not that difficult, but you require some basics to follow the lab seminar. So Sunday through it. So
See, it's this one. It's the other one. It doesn't go straight. It's
Yeah.
always
Up.
always up.
It's flat till 0 and from 0 it's up.
Yeah.
Something.
No,
But
it-
isn't
yeah.
there a boundary?
It's a straight line.
No, it's
Go-
just
go
y equal to
45
x.
degrees.
Yeah.
Till infinity, 0 to infinity, y equal to x.
Yeah.
And so if we do LELU forward, we are basically doing maximum of x over 0. So that's why we need that graph. And if we draw computational graph for LELU, then how will it look like? So, Sanas, can you draw a computational graph for the LELU? That is nice, but remember when we are doing computational graph, there is nothing like a vector or matrix.
Okay.
We should always think individual number.
Okay.
So let's say there are n numbers in the X, then how will the computational graph look like?
If there are n numbers within the x.
Yes.
Okay. So you have to do element-wise comparison.
Yeah.
So that this is the symbol for element-wise comparison.
So just draw the individual node x1, x2.
Okay. Okay.
Yeah, in the node.
Okay. So each of them will be compared with 0.
Yes.
So the
that's nice. Yeah. So finish it. Let's say the output is y. No, y is also vector.
Okay, y is also vector.
Mhm.
So compare each of them.
What I mean is, you can just do this. Yeah. So this is the output, and so Saros, where do you which line you don't understand?
The LELU forward I understand.
Mhm.
It's straightforward.
Mm-hmm.
The backward one. So the two parameters in it, so it's basically
You mean D out and cache?
yeah.
So you do not understand why there are two parameters? Okay. Can anybody explain why there are two parameters here?
Because the partial derivative depends on what was the input.
Mm-hmm.
So suppose there were two input, there was an input that was greater than 0,
Mm-hmm.
then even the derivative will have some value. So if it's less than 0, then your derivative also goes to 0. For-
Does it make sense?
So maybe can you explain through the
Okay, over here.
example? Yes.
Mhm.
So this is your function, right?
Right.
So if you are trying to get the derivative of this function, you are trying to differentiate it with respect to each of these variables,
Right.
partial derivative. So to if this value is greater than suppose for x1, the value is greater than 0, then it will have some output, right?
It will have same x1. Yeah.
So if you differentiate this function with respect to x1, the value will be related to this x1.
It will be 1, no? Like.
I mean, in this case, it will be 1.
Okay. Okay.
So we have to get to know what is the whether the x is greater than 0 or not, greater than or equal to 0 or not.
Oh, okay. So,
So,
okay,
for that reason, we need to retain the x, right?
Oh, okay. Okay. So whether to check whether one of these x1 to xn,
So
which
when
one
you're
is 1,
ta-
which one is 0.
when you're taking partial derivative, you need to know how the original variable was with for each of those variables. Like, what was the value
So that
to
is
determine
basically
the
your cache. That is basically your cache.
Yeah, that's why you store in the
Okay.
forward function itself. You store the input into a variable called cache, and that
Okay.
is passed to the backward function while computing the derivative.
Yeah.
So, Saros, can you write what is the D out in using those notations? Yeah, please write it. Let's say the loss is L.
Yeah. So it will be.
Let me bring some markers. Pascal, can write. So guys, try to write what is the D out and dx. Discuss. Yeah, everybody can have several.
D was your output layer.
Yes.
D out is the output of the last layer.
No, it is a derivative
Basically
of.
that's
That will
why.
be 10, right? There.
That's the still confusion. Not sure what it is.
What?
The D out.
You said it's the output of the last layer.
So it will be
it
derivative
will
of
give-
loss with respect to derivative of the function. The function of the last layer.
Mhm.
So the function of the last layer is the softmax.
It should give you 10 values,
Function.
right? Then
No, softmax is a different.
No, we are using softmax in this.
in the output layer.
So in this case should be this one, no? Del y, dl by del y, right? Because y is the output. And this is there in each of the layers, is the final layer.
This is the activation function. Man.
Yeah,
So
activation
it will
function
be,
of which layer? All the layers?
for everything except the last layer, right? N minus 1. If there are n layers, n minus 1
Last layer
layers.
also will have
Last
activation.
layer will be your loss function, right? The activation function will be the.
No, each layer has the activation function.
Yeah.
Uh,
This is the relo activation function is for the n minus 1 layers, and for the last layer you use the softmax.
Oh, yes, that's what I'm asking, like which layers?
So it will be
Yeah.
different, right? That's why I didn't say. This will be only for n minus 1 layers, not for all.
Okay, so you are using relu activation for all the hidden layers. Output layer you are using
Using
softmax.
softmax.
That's what I'm asking.
So basically,
So then it won't be in the loss part. Loss part will have a different thing.
So this D out will be not Y, I guess. It will be for.
But for this case, this is applicable.
For this case, since this is the activation function, the loss will be with respect to this. dx will be nothing but
Didn't we say that loss function is the total sum of all loss?
no loss is
But you're using softmax.
yeah. You're using softmax to get to convert the entire thing into a probability density function, and then the loss is nothing but the negative summation log of each of the probability divided by the number of inputs. See, this is the loss which is computed inside softmax. It's a negative summation of log.
What's the shape of X?
That varies for each layer. So initially it will be the output of first half and forward.
So what's your result, Saros?
In this case, this is our output y,
Uh-huh.
and if we have the loss equal log.
So can you write it in detailed form? Can you unpack it? Y is a vector.
Okay. So then d out also will be a vector.
And please use other
Yeah.
marker and throw it to the trash can.
Yeah.
And nobody can use it.
Yes, go on.
Mm-hmm.
We have to put here.
Okay. Mm-hmm.
So d out also will be a vector of n. So you have dl by dy1, then del l by del y2, and then del by del yn. So that will give you d out.
And what is the dx?
Dx.
Mm-hmm.
So dx will be
Do not try to solve it, just to write what we are trying to get with the
Yeah.
L. So
yeah.
it's almost the same with the DL. So what we want is, we want something like a DL with respect to X.
Right.
Yes, so please write.
It will be equal to d out because of this function.
Oh no, what I mean is with respect to DL. So
Oh, okay. So we got d by d.
Saros, I'm not asking you complex thing. It's,
dl by
yeah,
This
DL.
is one.
dx.
dl by dy, dy by dx.
No, it's just dl by dx.
It's just dl by
which is
dx.
dl by dx1 dx.
Yeah, so what I want is, what I mean is,
Oh, okay.
yeah, it's not complex thing. So we want this, right? And what is the dx1 over d L? dx1 over dl1 is dl over dy1 multiplied by dy1. So x1, right? Everybody clear? So, this is given. It is the first member in this D out. And what is this? What is the relationship between x1 and y1?
Input equal to output if it is greater than 0.
Pardon me?
The input value is equal to output for greater than 0, otherwise 0. X is equal to y for x greater or equal to 0.
So y1 will be either x1 or 0.
Yeah, so what's this value?
This will be like x for greater or equal to 0.
Pardon me?
1 for greater or equal to
Pascal,
0.
come here, right. Throw it.
Keep it here. Where there is.
Pascal, that is not right notation. That is not right mathematical notation. Right? So how will you write it?
X will go with x1.
Right. So this should be x1. Yeah. Okay. So we just it will be something like 1 0 1 0 something like that, right? If x is larger than 0, it should be 1. If it's less than 0, then it's a 0, right? Then why we need a cache here? Cache is, by the way, x.
Yes.
So do you see why we need a cache to get the derivative?
Because we have to know whether that x1 was greater than 0 or less than 0.
Yeah. So we need a cache and we have a D out, right?
Right.
So basically we have an original x and we have this output. Then can you get this from this formula? Can you now see what it is doing?
Okay, so initially we don't have anything then. And then cache is basically our x. X is we are storing x, restoring back. And then we are saying x.
What is the number 49?
Is just checking whether the input, each of them was greater than 0 or.
It's a 1 over 0.
Yeah, it's basically this one.
Yeah. And what is the dx?
Okay, so basically this is flowing inside. I mean, this one is flowing backward. So we are multiplying this one with the previous one. Basically whatever is coming from outside, D out.
Yeah, D out is this one,
Yeah.
and the Rx is this one.
Yeah,
So
so
we are
multiplying this.
Yeah, we are multiplying this
Yeah.
one. So now you understand
Yeah.
that. So is there any question about the value? No? Okay, let's continue. And so how many people took a neural net course here? Please raise your hand.
Online, but not
Online is okay. Online is okay. So you know what is going on now. So, Paul,
I'm taking it.
you are taking this semester. Yongtak, are you taking it or?
No.
So Yongtak, you have to devote like 2 hours per day
Okay.
to do a basic online neural netting. There is just too many. And it does not take too much, so you will probably have to catch up.
Okay.
Okay, so let's continue.
define the loss function.
So, Sanas, what is the self?
Self is the object of this class.
Mm-hmm.
The class is a fully connected neural net class, and we'll be passing all the parameters to this.
Yeah, so what's the difference between the function without self and with self?
Okay, I'm not written.
So,
Sorry, I have to write self. We have to write self for all the functions.
really?
Yeah, right.
Class.
Yeah, or it won't
is
work
class
because,
function. So
class
call
requires-
through its objects. First parameters will be itself.
Yeah.
But I think we can still do it.
No,
No.
I tried it and
No?
we get expecting expecting more
Okay,
arguments.
then let's fix them.
If we don't define self, then
Mhm.
those functions are internal functions of the class. It cannot be used like by an
Outside.
object.
By now.
Mhm.
You can internally
No, no,
use
no.
those functions.
So yeah,
It becomes a normal function, not class function.
so that was what I mean. We can use them internally,
Internally,
Yeah.
we can't
but
use
we
them.
cannot use it,
So it-
outside. So that was what I mean.
Yeah.
It's like a public versus
Oh,
private.
yeah.
Analog should be without self. It will be private, and with self it is public.
Yes.
It is analog, not
Yeah.
actual thing.
Yes.
Then in our case, it should work here.
No, if you want to
So
call through
if
object.
we call those functions only inside the class, like in the loss function, if we use them, it's okay.
Mhm.
But if we use this function outside of this class, like we define some fully connected net as FC, then things like FC that applying forward cannot be called,
Yeah.
right? Yeah.
And what I mean is, are we going to call this class from other function later?
We'll be calling it from another file. So this is like a library we created,
Oh, okay.
our own custom class for the network. Actually, the other functions we could have, only loss requires self because we'll be calling loss outside the class.
And we don't call.
We actually don't call, like
Yeah,
when
that's, yeah.
we actually don't call them, right? We call only the loss
Okay.
outside.
Okay, fair enough. So,
So in that case, we don't need that self in other functions.
Yeah.
We shouldn't need it. Actually, we
neither
have-
one don't need.
We don't.
Yeah. So we should remove it, right?
Yeah, that's why I'm not using it. It's only for this function.
So you mean in line number 41, we should remove self?
Yeah. I mean, there won't be any requirement because we won't be calling the.
Yeah, so
forward
we
type
should
of-
remove it, right?
Yeah. So I remember now why I didn't include it in the other.
Okay.
Without the self function, the Python method work as the static.
Mm-hmm.
So if you erase the
This
self,
function can be
Mhm.
solved
the function will
within
be the
this
static function. So
class.
if you call the functions, you cannot use the classes variable. There is a problem.
Oh.
So
Okay.
if you use the static function,
Uh-huh.
inside the you have to call the static variable to the static function.
Okay.
So in this function, you use the static variable or not? There is the problem.
No, we are not using, we are just using normal.
Yeah. Then
So,
you
so we
can-
need to leave the self.
Yeah.
Okay, let it. This is making sure that the input is of standard data type. We define a variable mode which is for differentiating between test mode and train mode. So we'll be calling the function for both training and testing. Only difference is when we are calling for testing, we'll be passing y. We'll be not passing y.
Is that if or if?
So if test is none, it should be test, else it should be train.
Train.
Again flattening the ring.
That should be input, no? INPG.
Right,
Okay.
It's
It's a variable name.
a variable name, so it.
INPG, okay.
Which line?
Okay, sorry.
59, it's like variable name or input. I get confused.
I plus 1.
You should use capital W.
Oh, sorry. the implementation of the forward pass for the first n-1 layer. And
Bring something new like going scrolling or something.
yeah.
Can you click up the lines to two lines?
No, after
No,
equal
after
to
equals
just
to,
start
you can
the.
just press enter so that it goes down. Okay.
Is this okay in Python?
If you use the backslash, that's okay. But now,
For using new line, just
Yes.
I think the black slash should be given. But here he is finding it difficult to say. So just
Yeah, so once you're done, I can just click back. Like this is just so.
So
you can
what is
see.
the right way to handle a situation like this? So,
use the backslash.
the black
Backslash.
slash.
mhm.
After equal,
Saru,
Backslash where?
after equals.
After equal to black.
Saru, please show him how to do that.
Like this?
Yeah. Done. That's it.
And is this still right way? Python is it is important for Python to write a beautiful code.
Yeah.
And what is the better way of writing this? Can anybody suggest? So, if not, let me show you. I think the right way is Are you sure this is a single backspace? What
A
to-
single
Single
backspace.
backspace.
Okay, so like this.
calculates the loss and the gradient, we are using the softmax function for calculating.
So let's go inside the softmax function. So make it full screen. Yeah. Okay, here's the softmax loss. Okay, Aishwarya, can you write a mathematical formula and try to understand what is going on here?
In that?
Oh yeah, so we'll use the blackboard and write what is the softmax and no, Sanas, you do it first.
Okay.
Yeah. And erase it first.
Okay.
Yeah.
So for it takes x and y as input. So first the x minus and
No. What is the softmax loss?
Softmax loss, you're asking the mathematical formula for that is,
Yeah, mathematical formula.
is e power xi divided by summation of e power
Everybody, is this right?
Yeah.
Okay.
So from what I understood is over here, this is the normal softmax loss, softmax calculation. But then if the value gets too large, there is something called as normalization which they do, where first you take the values and you subtract them with the maximum of the entire set, and then try to do this.
So the first line 721 is that normalization.
Yeah. And the second line does the exponent shifted.
The denominator.
Yeah, it
The
does.
sum of the exponent.
It gets the denominator basically. So the 723 gets 722 gets the denominator, and log props is shifted props.
Then what is the shape of G?
Z is a scalar.
Is G scalar?
Yeah, because we are summing the. Okay,
Oh.
no. Z is the number of classes in this case.
Number of classes. Any other opinion? Let's decide what's the shape of the G. You guys begin with the shape of X and decide what is the shape of shifted logit.
Shifted logits will be same as the shape of x, which is n comma c.
So
Yeah.
let's write it. Shape of the shifted logit is n comma c.